Hello, all. Good morning and good evening. Welcome to the Oracle Database training. Yeah. So, we have discussed in our last session a few concepts, few topics on the Oracle Database architecture. Before we do the recap, I just would like to have a quiz time with you people, try and understand and having some brush up on our learnings what we had in the past session. Okay. Okay. Can you guys see the screen? Quiz question. What are the two main components of an Oracle database instance or Oracle instance? Option A, data file and archive logs. Option B, memory structure and background processes. Option C, table and indexes. Option D, user and roles. Which option you think?
Option B.
Option B. Okay. Adam, Carl. If you guys are speaking in mute, please unmute and do speak. Do you guys also think option B or any other option? Okay, I'm not getting the responses. The right answer is option B. It's a combination of memory structure and background processes. We call it as an instance in the Oracle database. Okay, so the right answer is memory structure and background processes are called as an instance. Okay, so this is the first question. Let's go to the question number two. So what's that? Okay. Which memory structure is shared by all server and background processes in Oracle database instance? Which memory structure is shared by all servers and background processes in an Oracle database instance? Option A, PGA. Option B, SGA. Option C, control file. Option D, archive log files. Which which memory section you think is shared by all server and background processes in Oracle instance? Any clue with anyone? Just give a try, give a shot, right or wrong, that's fine.
SG.
Yes, Justin said SGA. Yes, system global area or shared global area, we call it as in the memory structure. So that is the shared by all server and background process in the Oracle instance. That's correct. The right answer is SGA. Yes. Okay, let's go to the next question. What is the purpose of system global area in Oracle? Option A, it stores operating system files. Option B, it holds shared memory structure used by the database instance. Option C, it is where user passwords are stored. And option D, it is backup storage area.
Option B.
Yeah, just now we discussed, right? It is a shared memory structure used by the database instance. Yes, option B. And the fourth question, when the Oracle instance starts, which of the following is allocated first? Data files, redo log files, memory structure and background processes. Option D, table spaces. Which one will be allocated first?
Um, Memory structures and background processes.
Yes, absolutely correct. That's the right answer. So whenever you start a database, it'll first starts with the allocation of memory and then background processes. Okay. Yeah. Which process is responsible for writing change data blocks from buffer cache to the data files on the disk? Option A, log writer.
TB, TB
Option
right, right.
DB writer.
B.
Yes. Option B, that's correct. DB writer. DB writer does writing the dirty buffers from buffer cache to the your disk data files, physical files. Okay. Then the final question: an Oracle instance can exist without the database file being available. Is this true or false? An Oracle instance can exist without the database files being available.
True. That is very true.
Yes, yes. Oracle instance can be available without your database being available. So that state, what we call, is no mount state. It's a no mount state. Okay. So if your database is available, then it's read write database open state. So before that, control file will be opened. That is a mount state. Then database will be opened. So no mount, and open the database. True. That's correct. Let's go back to our session, original session. Yeah. Okay. Yes. Architecture we are discussing, right? So let's recap again till what we have discussed on Friday. So we have discussed about the client process. So whenever a user connects, so what exactly happens? The user process will be initiated, and whenever the user requests for a information from the database, it goes through a listener. The listener will be deciding the whether that user should connect to server process or not. So listener will have a network information, IP address, port number, instance ID. All this information will be available in the listener. So this listener will be dynamically registered by the process called pmon. Okay, pmon will dynamically register the listener, database information in the listener. Okay, if you have a multiple instances, multiple databases, each will have a one pmon, right? So that pmon will register dynamically what database that user has to connect. Okay, so then once the server process goes to the user process goes to the server process takes care everything on behalf of user process. So then you know it will directly be allocated one PGA, that is a dedicated program area, global area, and then it will connect to the SGA and do the request and process whatever the data required by the user through the different processes, different memory architecture, and different background processes it uses. Okay, so for example, it is a select process, then it goes to the first it goes to the database buffer cache. If the data is available in the database buffer cache, it reads from there and gets back to the user. If it is not available, then it will connect to the data files and read that data and keep the data in the database buffer cache. And then from there, it fetches and gives to the user. Okay, application basically. Okay, so likewise, we have in an SGA we have a database buffer cache, shared pool, result, and then large pool, Java pool, and stream pool, and we have a different uh, background processes like DB writer, checkpoint, log writer, arc writer, flashback log, mmon, smon, pmon, reco, mmnl, and others. We have a lot many background processes. We will be discussing on only important background processes. Okay, so let's go back to the our server. So I will start from there. Okay. So let me share my screen to you all. So I'm going to connect. Sorry, what happened? You guys able to see my mobile extreme session? Okay. So I'm connecting to my. I have built one lab mission, Oracle Lab one. So I'm going to connect to it. So this is a Oracle instance, Oracle database server running. Okay. So let me connect to my database. So right now, let me check whether I'm in a right instance or not. Okay, Oracle Home is correct. Oracle SID. SID means system identifier. So Oracle DB is my SID. Okay. So you can also do like this Aura env. If you have a multiple instances, you can it'll ask like which SID to be connected. You can give. Right now we are connecting to the ORCL DB only. So I'm just giving an enter. So it remains unchanged. So now I can connect to the SQL plus slash s is DBA. Okay, SQL plus is a tool, client tool, slash is a user, admin user, as is DBA is the privilege. Okay, so I'm connecting to the database with this. Okay, right now let's see whether my database is up and running or it's an idle. Okay, right now connected on an idle instance, which means my database instance is not up. Okay, so let's say only instance we will start up. Okay, start up, no mount. We are doing startup no mount. So what will happen? Startup no mount, only instance will be available. Your database will not be open. So what happened here? So immediately it it uh, it allocated a memory. Okay. So within that memory, fixed size, variable size, database buffer, redo buffers. Okay. So let's talk about this. Uh, each and every component here. So these are all part of the SGA only. Okay. So let's go to our deck. Okay. Um, so so whenever you start a database, whenever you start an instance, basically it touches first the memory. Okay. So before it touches the memory, there is a parameter file. Okay. First it reads that. So parameter file, we call it as an initialization file as well. So whenever you start up instance, it reads this parameter file. Okay. So this parameter will have all the memory structure allocation details. It's a readable file. Two types, like it can be human readable or SP file. SP file or P file. Okay. SP file is a binary file and P file is a human readable file. So we can read the all the allocations in the P file. SP file you cannot read. Okay. So first Oracle server will read this parameter file or initialization file, then allocates whatever the amounts or allocations we have added in the parameter file. The same way it will allocate the memory for the SGA, PGA, and starts the background process, and your instance will be ready, available. Okay. So first, whenever you start, it reads the parameter file, then it makes your memory allocated and background process started. So that is nothing but an instance. So your instance will be available when you start your database instance. Okay. So let's magnify on the SGA part here. Okay. SGA. Let me get my. Okay. So SGA part. Okay. So SGA, shared global area, will have a multiple components. So first one is a shared pool. The second one is a uh, data dictionary, not data dictionary. Wait a minute. This is only shared pool related. Okay. Mm, okay. So first one is a shared pool. Second one is a data buffer cache. The third one is large pool. Fourth one is Java pool, and fifth one is streams pool. So let's go one by one. So what is a shared pool, and then what it contains actually? Yeah. So you're able to see the shared pool, right? Shared pool, one of the memory component from the SGA. So shared pool basically uses to store most recently executed SQL statements. Okay, and most recently used data definitions, and it consists of two key performance related memory structures. One is library cache and the other one data dictionary cache. So so it's very important, memory component. We all have to understand and remember this. So this is very important. Okay, uh, for your database performance also, when you want to tune your database performance. So this is one of the place where you can look at parameters and change and make your database optimize. Okay, so let's look at what exactly library cache is having. Okay, it again divided two parts, right? It consists of two key performance related memory structures. So one structure is library cache. So library cache is having a shared SQL area, okay, where your SQL statements will be passed, and your SQL execution plans will be created and stored, and and then you know uh, then you go to the SQL private SQL area. This is in the shared server only. If it is a dedicated server, this will not come. Okay, and then dictionary cache. What is the data dictionary cache? Data dictionary cache will have all the objects information in your database. So table, privilege, your data file locations, all that information will be available in the data dictionary cache. Okay, so data dictionary cache will have a object related information. It's a metadata. Okay, it's a metadata information it will have. Okay, so let's look at our presentation. Okay, shared pool. Okay, so shared pool is like a buffer for all SQL statements. So Oracle parsing algorithm ensures that identical SQL statements do not have to be passed each time they are executed. So whenever you execute a query, the query first it will be stored in the shared pool only. Okay, in the library cache basically. So then uh, it will go to the parsing. Okay, so parsing algorithm will be there. So syntax, semantical, and also semantical will be like your object information it will check. Syntax will be like whether you are given a right syntax or not. Okay, any spelling mistakes, if you are missing any keywords, the syntax check will be ensuring that you're giving the right SQL statement. S- Semantic is like if you are giving a select star from an object, so whether that object is available or not, and whether that user is having an access to that particular object or not, the semantic check will be checking that. Okay, so and again as I told you, it has a two key performance related memory structures: data dictionary and library cache. Okay, so the purpose of this shared pool is to store most recently executed SQL statements and most recently used data definitions. Okay, so what exactly the library cache? Okay, so library cache pool contains Oracle library cache, which responsible for collecting, parsing, interpreting, and executing all the SQL statement that go into the Oracle database. Again, it consists of two different areas: shared SQL area and PLSQL package procedures. So what is a shared SQL area? The shared SQL area stores each SQL statement executed in the database. This area allows SQL execution plans to be reused by many users. Okay, and what is a PLSQL package and procedure contains? PLSQL area used to hold parsed and compiled PLSQL program units, allowing the execution plans to be shared by many users. All the packages information will be permanently stored here. All your PLSQL package information permanently stored in PLSQL package and procedure area. Okay. So the purpose of this library cache is to avoid reparsing the same query repeatedly, and this library cache will have an execution plan which reuse that execution plans to improve your performance. Okay, that reduces your CPU uses by skipping redundant parsing. It allows a SQL query to go through the soft parsing. So whenever you execute a first time your SQL query, it goes through the hard parsing, which means like all your syntax, semantic, and your execution plan will be created for that through the optimizer. Okay, so optimizer will create that execution plan. That execution plan will be stored in the uh, library cache. Okay, this process we call it as hard parsing. The same query you repeat, you execute again, so it need not to go through all the parsing steps. Okay, it will have a hash value. Execution plan will be directly executed in your processes and gets the data to you. Okay, so we'll discuss in the real time also how this works. Okay, so right now you just remember like what library cache is used for. Okay, and dictionary cache, as I told you, like it'll have all the object related information. Okay, it'll be used when you have executed a query to require some object information, column information, or you know index or table information. Then this data dictionary be used to verify whether your database is having particular object and your user is having particular privilege or not to access that particular object. Okay. So metadata, it will be stored, not the real tables and views. It is a metadata, data about data. Okay, so it is a small amount of area. You cannot have your tables and views stored here directly. It is just a metadata only. Okay, not the real data of your tables and views or indexes, whatever. Okay, so most oftenly, all the objects will be checked with the data dictionary cache. Whenever there is a data is not available in the data dictionary cache, what will happen is like it will take the data from the system table space. Okay, I'll talk about that also. So when it will go to the system table space and get the data when it is not having that particular object information. Okay, I'll talk about that in the select statement example. So right now you just remember what is data dictionary purpose. So it is used to cache data dictionary related information in RAM for a quick access. Okay, all your metadata will be there for a quick access of your objects. Okay, so the next memory component is, what is your next memory component? Uh, this is about the shared pool, right? So the next memory component is buffer, database buffer cache. Okay, so let's look at this database buffer cache in a magnifier. Yeah, so what is database buffer cache? The database buffer cache is where Oracle stores data blocks temporarily. Okay, and for the processing, any data coming or going out of the database will pass through the database buffer cache only. Okay, so any data, when you wanted to read a data through this SQL statement, that data also will be placed from the data file to the database buffer cache first, and from there it'll be fetched to the client. For example, if you are writing data also, first your server process will check whether the data blocks are available or not in the database buffer cache. If it is not available, then it goes to the your disk, and from disk it will fetches that particular blocks and place that in the database buffer cache, and then it modifies those blocks that that is called like a disk read. So when you are reading from directly from the disk and placing it in the buffer cache is called a disk read. So once you modify those data blocks, and those modified data will be again written into the data file, your storage or disk. Okay, so this is like mediating between your storage and the server process. So whenever a server process comes, it first check the database buffer cache only, then it goes to the uh, disk. If it is not available in the buffer cache, it goes to the disk. From the disk it will put the information back to the buffer cache. Okay, so the buffer cache are organized in the two list, the write list and the recently used list. So let us understand this information a little more. So what is write list, and how your um, buffer cache works with the write list and LRU. Okay, so you understand, right? Or no? Whenever a query request for information, that server process will look the data in the buffer pool first. Okay, the first look in the database buffer cache to determine if the requested information happens to be already located in your buffer cache or not. If the information is available, it would not need to be retrieved from the disk. Okay, so that way, like it improve the performance, so you need not to go to the disk every time and read the data. If the information is not in the database buffer cache, the server process retrieve the information from the disk and stores it to the cache. Okay, so keep in mind that information read from disk read is a block at a time, so it will be reading the information in terms of a blocks. Okay, not as a row. For example, if you are requesting for a row, it won't read the information like in a row wise. It'll be reading in a block wise. Okay, so that block size will be 8 kb. Okay, so because blocks are the smallest units in the storage to manage the storage, okay, and optimally, that I will talk about like in the physical and logical structure of the database. I'll talk about like how blocks, segments, extends, table spaces and everything. So just remember, so the database in the database buffer cache, the data will be stored in the blocks only. Okay, and it reads the information from the data file also at a block level only. Okay, so so when the database blocks are kept in the database buffer cache, okay, according to the LRU, least recently used algorithm. Okay, so in the SQL server also you will hear about these terminologies, right? LRU and MRU, most recently used and least recently used uh, blocks. Okay, so the least recently used algorithm, which are like more aged memory blocks basically. Okay, so if you are not using any aged blocks, so those will be cleared, those will be freed up for accessing the or adding the newly database blocks. Or example, if you are having your database buffer cache full, so it will first check your least recently used blocks to flush it out, to keep the newly uh, if you wanted to keep your new data blocks in the buffer cache. Okay, so in this buffer cache, right, database buffer cache, there are three states. First state is unused, second state is clean, the third state is dirty. Okay, so let's talk about what is unused. So a buffer cache is available for use in the unused state. Okay, it has never been used or is currently unused. Okay, whatever the blocks is mentioned as a state unused, so those are all like completely available for use for your newly added data blocks. And clean, a buffer cache that was used earlier and the data is written to the disk. So those blocks we call it as clean. Okay, so those we can make it as unused again, make it free, and you can reuse those clean blocks also. And the third one is dirty, a buffer cache that has been modified data but that has not been written to your disk is called as a dirty buffers. Okay, so those dirty buffers until it returns to your disk, those will not be moved to a clean. Okay, so dirty you cannot flush because those needs to be written to your hard drive or disk or data files. Okay, so once dirty reads returns to your disk, it will move to a clean state. So in the clean state, your you will be mentioned that your data blocks have been moved to the disk. Then it moves to the unused. Unused means like it is again available for reusing those blocks. Okay, so it is very important to understand these states. And again, this buffer cache, right, each buffer has one or two access modes. That one is like pinned, which means like you wanted to have that block be available for longer time. Okay, a buffer is pinned so it does not age out of memory. Okay, so if you wanted to have some information to be pinned, you can use this mode, pinned mode. So it will not be going to the dirty, clean or unused. It will be like pinned. So whenever you wanted to access the data will be available if you make that that buffer as a pinned. Okay, for some queries if you wanted to have this data be available always in this database, so you can pin that in the buffer. Okay, and then other one is free, which means unpinned. Okay, so it will be used again for unused, clean, dirty. Whenever your block is free, then it can go through all other different states: unused, clean and dirty. Okay, so the purpose of this buffer cache is to Oracle receives a request to retrieve a data. It will first check the internal memory structures to see whether the data is already in the buffer or not. So this process will allow the server to avoid unnecessary IO. It need not to read the data file again and again when there is a data available in the buffer cache. So therefore, this enables a great performance when we obtain updated data. Okay, so this plays a major role for your database performance. Okay, so this is the buffer cache. Okay, and we have another memory component called redo buffer cache. Okay, what is this redo buffer cache? This redo buffer cache is one which holds the information about the changes made to the database. Okay, so it will only keep the information of the changes. Okay, for example, if you are updating a data, okay, so it will have both the informations, updated data and before you update what data it has. Okay, it will have a change vector information basically. So what time the data is updated, which row, which block updated, all that information will be available in this redo buffer cache. So just remember, so this will have all your changes, vector changes. Okay, so it will have the uh, changes you made, and it will also have the previous backup of those data blocks before the changes and after the changes basically. Okay, so all that information will be available, and also along with that the date, time and which data block it has changed, all that information also will be available in the redo buffer cache. Okay, so this redo buffer cache will be used at the time of database recovery. Okay, because you will have both, right, previous one and current change also. Okay, before the change, after the change, both will be available at the time of database recovery. You can roll forward or roll back with this RBC, redo log buffer cache. So that's it. Redo log buffer cache, very simple. It holds the changes, vector changes. That's all. Okay. So we'll talk about in the update statement how redo buffer cache coming into the picture, and do the uh, do its own job there. Okay. Let's go to the next slide. Large pool. So large pool is one of the memory component. This is a like another place where we use it for the large IO operations. Basically, if you wanted to do the backup and recovery, it requires a large IO information, right? So it needs to store a lot of information to restore the database, and even the backup also, it stores a lot of information while you're doing the backup. Not only backup and restore, it also uses when you are having a extensive queries, like very big large queries, server extensive queries, like expensive queries also will be used by the large pool. Okay. So this is basically an extra storage, extra memory, not a storage, I would say extra memory for you to perform uh, large IO operations in your database server. So this the purpose of the large pool is to avoid contention in the shared pool during large memory allocations. As I said, like backup recovery or large queries. If you are running a lot of uh, extensive shorting, all these things, at that time a large pool will be coming into the picture and does its job to share some memory to those uh, statements or queries. Okay. And then java pool is dedicated for the java applications. If you have a java uh, JVM, Java Virtual Machine, or Java clients, your application is written in the Java. At that time, Java pool will come into the picture. Okay, this is an optional. Okay, when you have a application written and you are having a JVMs, at that time only Java pool memory will come. Otherwise, Java pool memory will not be coming into the picture at all. Okay, so it purely depends on what application you are using. So it will actually optimizes memory uses for the Java based operations. So this is one of the optional memory component. Okay, memory structure. And then Java pool, we have another called stream pool. So stream pool is used when this is also another optional memory structure. Okay, so this will be only used to manage memory for Oracle streams. Okay, so which handles the data replication and message queuing. So if you're having a data replication between certain objects, tables, views, or indexes, so that time the stream pool will come. Okay, if you have a distributed database architecture, you wanted to replicate a certain tables to another database, at that time stream pool will come into the picture. It supports the data replication and messaging tasks. Okay. So to configure the stream pool, stream underscore pool underscore stream size is the parameter to configure it. So in a single database, you can specify that streams memory be allocated from a new pool in the SDA called streams pool. Okay. So basically, this will come into the picture if you wanted to, enable the replication. So what next? Okay, next we have a programmable area, program global area. So till now, any questions on these memory components? Any questions on this memory components?
So far it's good.
It's good. Okay, you will get even more clarity when we discuss about the specific examples where, like, select and update, how each and every component works. Okay, how each and every component plays its role in those examples. Okay, so just
Yeah.
briefing all this and structures for your understanding. So we will see, like, how it is actually behaving in the real time. Okay, so then we have completed SGA. Okay, SGA is done. So then what is next? We have a background processes. Okay, when when you start up a database, along with SGA, background process also be started. Okay, so let's see. So what background processes started? So let us see, like, in your Oracle database, we have just started the instance, right? So let's see. Okay, so right now the database instance is in a no known state, which means the instance is started. So let's see, like, whether the processes are started or not. So to check the processes, ps ef grep. To check all the Oracle processes, just simply type ora. Now you see, right, all the processes are available here: pmon, vktm, mmn, and log writer, db writer, and all processes are available here. Okay, all the background processes are running now because your instance is ready. Okay, available. So when your instance is available, along with the memory structure, your processes also be started. Okay, the combination of both memory structure and processes, background processes, are called as an instance, right? We talked about that. So in a real time, this is how it looks: your processes running. Okay, let's connect back our database again. It's dba. Your database is in Mount Node. Earlier it's shown ideal instance, but now it is showing you connected to the instance. Okay, so now you can what we have to do. Yeah, we talked about the background processes, right? Let's look at the mandatory background processes that useful in the architecture. We need to understand and connect to them. Okay, so let's look at that. So before we go into the background processes, we have another memory component called PGA, Programmable Global Area. Okay, so what is the PGA? So this is a memory reserved for each user process connecting to an Oracle database instance, allocated when process is created, reallocated when the process is terminated. Okay, so this is something like, used by only one per process. So whenever a user process is initiated, it it will have a dedicated server process. For that server process, one PGA will be allocated. So one of the memory component, memory structure, a PGA, that PGA will be allocated to each and every server process. So this will have all the session information, also hash area, short area, bitmap merge area, also runtime area, persistent area. Multiple areas it will have. PGA again will have. So it can be different, distinguished, like, SQL work area and a private SQL area. Okay, so let's talk about a little bit on that. Okay, so the PG is a non-shared memory. So this is, like, only a dedicated memory that given to each server process when a user requests for an information. Okay, so basically uh, the shared memory, like, this is a non-shared memory, right? This will be allocated for your server process. It stores data and control information specific to the process, okay, such as like session information it will be storing. And like when I say session information, it stores the user session variable and the session state also, it is active or it is still like sleeping. All this information will be available in this session information. And work area and SQL work area, it will have the cursor work area, which has the runtime memory for cursor execution, and memory for memory intensive operations. If you are working on the shorting, hash join, etc., this like PG only shares some memory for those operations also. Okay. And if you are having a you know SQL or PLSQL uh, mm, executions, that execution data also will be stored here. Information needed for processing, querying, and code. Also, this private SQL area is there, right? That holds the details of the SQL statement being executed. Okay. So, so this is the PGA, program global area. So this is one of the memory uh, component and the memory structures. So it will be dedicatedly be assigned to each and every process that runs when a user request from a client. Okay. So this is the PGA. So memory is the total memory is distinguished to two structures, right? SGA and PGA. So this is the PGA. Okay. So now let's talk about the background processes. So we have different background processes, right? So I have differentiated mandatory background processes and optional background process also. So let's look at what is background processes. So background processes maintains and enforces relationship between physical and memory structures. Okay. So there are several background processes to manage the memory when Oracle is started up. So these processes together with the memory structure form a heart of a Oracle. Okay. So when an Oracle instance is started, the processes are created to perform database works and to manage the connections to different users. Okay. So in a simple analogy, right? I'll talk about. So you will be correlate about this background processes. If you're a human, okay, and you know how many phone numbers you can memorize? At least one, two, or three maximum, right? If you are having 100 phone numbers, we cannot remember and memorize all the 100 phone numbers. So the most recently used phone numbers, maybe your wives, your kids, your closed relations, you will be able to remember. So that is like your memory. Okay. So you will remember those phone numbers in your memory. Okay. But when you have a more phone numbers that you want to keep stored, either you will place them in your phone contacts list, or you can write them in the some write them somewhere in the book. Okay. So okay, to write them in the book or write them in the phone, what you do, you'll use a different uh, ways, right? You will use your you know how you can write them in the phone, or sorry, how you can update them in the phone. You will open up the mobile with your hands, and you can just type the phone number and then save it, right? Okay. You will use your hands for it. Okay. So here the background processes works as a hands only. Okay. Whatever the job needs to be done, it will be done with your hands. The same way in the Oracle, it will be done with the background processes. Okay. So without your hands, you won't be able to update your mobile, or you won't be able to write those phone numbers in your book, right? So similarly, okay, a simple analogy just to correlate how background processes are very relative in the Oracle database. Okay. So we have categorized mandatory background processes and optional background processes. So we'll talk about this mandatory background processes. Let's see, like, first process is database writer. Okay, so database writers writes the data from the database buffer cache to the uh, storage or physical data files. Okay, you have a database buffer cache. Okay, database buffer cache. So then it will go to the DB writer. Okay, and then from DB writer it goes to the storage. Okay, so it will be in the form of blocks only. Okay, so the, the database buffer cache will be in the blocks only. I told you, right, in the memory structure. So database buffer cache will have data in the form of blocks. Okay, so this storage is the actual data, like your physical files. Okay, so whenever you wanted to update the information, you will update the database buffer cache first. Okay, first you will update the database buffer cache. From there the updated blocks will go to the storage through the database writer. So database writer will do that job to move the dirty blocks. I told you, right, dirty blocks are like the blocks which are updated but not written in the storage. So those dirty blocks will be written to the storage via with the help of database writer. Okay, if you are having 100 users are doing the same different update statements, you will have 100 database writer processes running for them. Okay, that's what DB writer will have a let me go back. DBWN. So N means number of processes. You see, right? DBWN. N means number of processes. Okay, so that's where DB writer comes into the picture to write the dirty buffers from the database buffer cache to the storage, your physical files, data files. Okay, so when this DB writer comes into the picture, okay, when there is a checkpoint occurs, when a checkpoint occurs, this database writer will be invoked to write the database dirty blocks from the database buffer cache to the storage. And again, dirty buffers reach its threshold. When the dirty buffers reach its threshold, also database writer comes into the picture and writes the data to the physical files. And then when there is no free buffers, I talked about, right, free buffers. What are those? Okay, so when there is no free buffers to hold the new data, that time also the database writer will come into the picture and write that block information to the dirty buffer block information to the physical files. And timeout, when there is a timeout occurs, also DB writer comes into the picture and writes the data. Okay, so these are the cases where DB writer comes and writes the data. Okay, you understand, DB writer is to write the data from buffer cache to the physical file storage. Okay, when it comes, so checkpoint occurs when dirty buffers reaches thresholds, when there is no space in the buffer cache, when there is a timeout. Okay, next, so log writer. What is log writer? So log writer actually writes the log information. Okay, so your let me see, like there's a picture here. Okay, so log writer writes the redo log buffer information to the redo log files. Okay, log writer writes the redo log. Redo log will have a changes, vector changes. Okay, vector changes. Okay, those will be written to the redo log files. Redo log files are physical files again. Okay, storage only, within the storage physical files. Okay, So all control file, data file, redo log file, these are all physical files only. So redo log buffer will have information of changes that are modified in the database buffer cache, and before modified, that information also will be there in the redo log. So how long it will be there in the redo log? Sometime it will have a space constraint, right? When it fills, 1/3 fills, then it immediately invokes the log writer. Okay, this immediately invokes the log writer. That log writer writes the information with which available in the redo log buffer memory component to the permanent storage redo log files, physical files. Okay, so very simple, right? So all the change informations will be written to the redo log files through the log writer. So when this log writer will be invoked? So when 1/3 full of your redo log buffer. Okay, and when there is a 1 MB in of redo. Okay, 1 MB of redo. Okay, and every 3 seconds by default, this log writer process will run and write the data to the redo logs. Okay, and then again, before database writer writes, before database writer writes, this point you need to really highlight, because this is very important, right? So because whenever user, okay, updated a data, okay, so then it will be updated in the SGA, right? SGA, within a SGA DBCC. Okay, he will update, he will not update directly in the storage. Okay, he will update in the database buffer cache only. Then this information first, okay, it will, whatever the changes he had made, it will move to the buffer cache. Okay, redo buffer cache. Then immediately user will get a response, commit happened. Okay, your data is updated. Okay, it will not wait for db writer come to picture and write the data from here to here. Okay, it will not wait for that. If it waits for that information, it will take a lot of time to do a commit transaction, right? So you don't need to wait for that, because that changes will be available here. In case of roll forward, roll back, we can use this redo log buffer and redo log files for that. Okay, so it won't wait for that db writer to write the dirty buffers to the data files. It will just, whenever this update is happened from database buffer cache to the redo log buffer, immediately user gets a response that your data has been updated. Okay, the commit is happened. That's what he is saying. Okay, before db writer writes. Okay, so these are all the cases when log writer comes into the picture and writes the changes to the redo log files. Am I clear? Okay, next, the background process is SMON, system monitor. System monitor is the background processes responsible for performing the roll forward changes in the redo. Just now we talked about the redo, right? What information redo has. This SMON process will come into the picture to perform the redo, like roll forward. Okay, instance recovery, wherein whenever your database is shut down or crash happens. Okay, so this SMON will only come into the picture. Okay, it does the database recovery. When you start database next time, this SMON will recover the database. Okay, so how it will recover? It will reads the redo logs and roll forward. Okay, when you have an instance crash or power failure or abrupt shutdown of your database instance, when you start a database next time, this SMON will recover the database. Okay, and reads the redo logs and roll forward to a original state. How before the before database goes offline, how it is in the state. All uncommitted transactions and committed transactions will be rolled forward. Okay, and it will be available for read write operations. So this will make sure that your database is consistent. Okay, Let's go back to the next one, process monitor, PMON. So PMON is one of the background process, is responsible for registering database with the listener. It does the dynamic registration, I told you, right? While I'm talking about the listener. So PMON is one which will do the dynamic registration of the database in the listener. And also it has other tasks also, not only just doing the dynamic registration of the database. It also have the other tasks. So whenever user session fails or goes to idle session due to the network discussion or anything, it cleans up that user session. Okay, so it will cleans up that user session. So whenever there is a session is idle or it is having network issue, it will clean that session. Okay, so so basically where that session information will be there, PGA, right? So that session information will be cleaned with this PMON. And also it does the releasing locks and releasing the restarting the dead dispatches. So dispatches will come into the picture, like when you have a shared server process. We talked about the dispatcher concept also. So that is how a PMON background process works. So next, this is one more important background process, mandatory background process, checkpoint. So checkpoint is does a lot of updates here. So whenever um you know you updated data, okay, so checkpoint regularly process update to the control file header and data file header. Okay, so this checkpoint will do update the control file header and data file headers, okay, with the uh, SCN number, okay, the system change number, or what we call yeah, SCN is a system change number only. So this keeps the database consistency. Okay, this keeps the database in consistent state. Okay, this will update SCN along with control file headers. Okay, so this will update the SCN in the data files header and control file headers. Okay, if the data file control file are not updated, then your database would be under inconsistent state. Okay, so when this checkpoint is not updating your data file and control files, then your database will be in inconsistent state. At that time, recovery of your database restore won't happen during crash. Whenever there is a crash, SCN, this checkpoint will plays a major role to identify which block needs to be recovered, which blocks has been updated. All those information will be available with the SCN, system change number, in the database files headers and control file header also. Okay, so this is very important. So when this checkpoint will come, so let's see what are all the different stages or places checkpoint will be invoked. So one is signaling DB writer at checkpoints. I told you, right, when checkpoint happens, DB writer writes the data to the data files from the database buffer cache. Okay, signaling DB writer, this will signals the DB writer to write the data. Okay, and also updating the data file headers with the checkpoint information. Okay, at that time checkpoint will come, and updating the control file with the checkpoint information. Okay, you have to remember this SCN, system change number. Okay, so this change number will be very important to make your database in consistent state. If there is a mismatch with the SCN number, if it is not, checkpoint is not writing or missing any SCN, then your database will be in an inconsistent state. Okay, so next, archiver. So archiver is another background process. This is an optional background process. When your database server is in archive mode, then only archiver process will come into the picture. If it is not in archive mode, then archive process will not come into the picture. Okay, this comes only when your database is in archive log mode. If not in archive mode, no archive logs will be generated. your redo logs will be overwritten again and again. Okay, so when you have enabled an archive log mode from redo log files, these are physical files only, right? The redo log files. Okay, so physical files. Okay, so that redo log files will be archived to archive log files when you have a archive log mode enabled. So whenever redo log gets filled, okay, immediately this will be backed up to the archive log. Okay, so again and again this redo log, you know, it will be freed up once this is moved to the redo log files, sorry, archive files. This redo log file will be free. So in SQL also you will have this log, right? Log file, the same transaction logs will be log information will be back to this transaction log, and then transaction that log file will be freed up. The similar way it will happen here also. That will be taken care by the archiver. Okay, so automatically archives online redo logs when archive log mode is set, and preserves the record of all changes made to the database. So permanently it stores these backups. So whenever, like, you know, at any point in time you wanted to go back to certain date, certain time, recovery point in time, okay, you can do with this archive logs file recovery. You can do point in time recovery with archive logs. For example, you have a backup uh, Sunday or Saturday. Okay, you have a Saturday backup, so you can go to the Saturday, and you wanted to go to 12 p.m. using this archive logs and the backup. You can go to the 12 p.m. point in time. Okay, so this archiver process will do writing those archive log informations, sorry, redo log file information to the archive log files. It is basically backing up the redo log information, all the changes information to the archive logs. Archived is nothing but a backup only, right? So that's what this archiver does. Clear? Any questions till now? Am I clear? Any clarity is missing?
Yes.
You're
No,
getting
it's
you're
good.
getting right? Okay.
Yes, yes.
Yeah. All right. So let's go to the Oracle files. Okay. So we'll talk about this. Oracle have a different files: control files, data files, redo log files, archive files, parameter files, server parameter files, nothing but initialization file or server parameter file, SP file, and alert log file and trace files. Okay. So let's see, like, you know, now our database is in mount state. Sorry, no mount state. How to make our database in mount state? What is the command? Mount. So what is the command? Oh, sorry, I have not written here. So now you have no mount. Now you can just mention alter database mount. So what will happen here? Your instance will start reading the control file. Okay, your instance will start reading the control file. Control file is one of the critical file in the database. If you are not having control file, your control file is missing, then your database won't be able to open. Okay, so now your database in mount state. Earlier only instance started, so that is a no mount state. So now your database is in mount state. When you say your database in mount state, which means your control file is opened. Okay, control file was written, read and open. Okay, So what is the next state? You need to open the database, right? So before that, I'll just quickly query this open mode. What is the open mode? It is in mounted. Okay, it is in mounted state. So now the same command, alter database open. Okay, earlier we mounted, now we are trying to open. Earlier we only opened the control file. Now we are going to open the data files. Okay, data files and redo log files. Yes, your database in open state. Let's see what is the state now. Read write, which means a client can connect to the database and do the read write operations. He can read, he can write. Okay, so in these two stages, one stage control file is opened, another stage the database files are opened. First control file will be opened. Okay, so then data file will be opened. So let's talk about, like, what are these different files. Okay, so control files just now I talked about. Okay, and data file are the files where we actually stores the user information, actual data. And redo log files, you all know, it is a changes. Okay, all the changes will be stored in the redo log files. Archive log files, all the changes backed up to the archive log files, which are nothing but archive log files. Okay, and parameter files, all the initialization parameter information will be available in this parameter file. It can be a p file or sp file. Okay, so p file is one we can read. Okay, sorry, p file readable. Sp file is binary, you cannot read. Only Oracle server can read this sp file, but this file you can read. Okay, so I will show you those files, like in the classes, coming up classes, or also now also I can show you this show parameter. Okay, you can see all this informations. So now it is running with the sp file. Okay, so in this location, you see, right, in this location, dbs. Okay, cd dollar oracle underscore home slash dbs. Okay, ls hyphen ltr. You can see init.ora. This is the parameter file, initialization parameter file. Let's see, like, what information it has. See, these are all configuration informations, your database name, your audit file destination, memory, sga memory, all information you can configure in this. These are all default parameters. You can add many more parameters here. Okay, so yeah, I just get it. Okay, so this is your parameter file. Okay, next, alert log and trace. Alert log is where, like, your all Oracle alerts, Oracle errors, all each and every information where, of the database will be stored here. Okay, so how your database is behaving, how your database logs are created. If you are having any issues with the database, those errors will be logged here in this alert log. Okay, you can, when you will day in day out, you will work with this alert log as a DBA. Okay, to monitor your alerts, errors or errors, etc. So trace files, again, these are like, audit files. Like, it will have a granular information, so you will only see basic stuffs in the alert log, but if you wanted to see granular information, trace files will be there. Okay, so more information will be there in the trace files. Okay, right, so yeah, you can see here control files, data files, online radio log files, parameter files, backup files, archive log files, password file, and alert file. So password file is one, like, we will be having in the server. So this will have a user information, the admin user information to connect from the remote. So when a database admin wanted to connect remotely, this password file will be used to connect to the database and do the administrative activities. Okay, So let's see, like, the distinguish between Oracle database physical and logical. So the physical database structure looks like control file, redo log file, and data files only. That CRD, control, redo, and data file. So the physical storage structures are simply file that stores the data. When you execute create database, okay, when you creating a create database, it'll by default it will create control file, redo log file, and data file. Okay, CRD, Oracle creates CRD files, control, redo log files, and data files. Those are physical files, you can see them with your eyes. Okay, this CRD files, you can see them with your eyes. Okay, so let me show you how I can see them uh, in the Oracle server. Okay, let me there's a view called db underscore data files. Okay, so I will show you guys that. Okay, let me connect. So select file name, table space, bytes. It will show you in the GB as a size MB from db underscore data underscore files. This is the view. You can see the data file locations. These are the locations, okay, where your data files are existing. Okay, your data files, not the control files and redo log files. For control file, redo log files, we can again query some other from the database files only. Okay, you can get the control files and redo log files also. Okay, so these are like your actual data files. Let's see, like we'll go to this location. We can also see the control file and data log files also, redo log files also. Okay, so these are all data files. Okay, you have a system, sysocs, user, under table. These are all default table spaces created when you create a database. Okay, these are very important. Sys and system. Okay, system and sys are very important table spaces for your database. Okay, so mandatory table spaces, I would say. They must be online as well. Okay, so system is used for core functionalities like data dictionaries, v views. All this information will be there. Okay, and sysocs used for additional database components like OEM, AWR reports, ADM reports. All that information will be available in the sysocs. Okay, and user table space is like actual users data will be stored in the user table space, and undo table space, like it stores the uh, undo segments. Okay, redo segments information. I will talk about this undo in the update query example. Okay, so this is how you can see the data file location, and cd dot ls Oracle DB. You can see control file, data file, online log files. You can see control file here. Okay, you can see this is a control file .ctl. Okay, so your data file by default will have a .dbf extension. Control file will have a .ctl extension. Okay, and then cd online log. Okay, oh, sorry, what is cd dot okay, cd online. Okay, there you can see the online redo log files. Okay, these are all you can see with the eyes. These are physical files. Okay, without your, like, these are all can be watched with your eyes right now. There are some other components, storage components, you cannot see them with your eyes. Those are all called as a logical structure, logical storage structure. Okay, we will talk about that also. So database will have a logical and physical. So logical is like, Oracle database uses a logical storage structure for fine graded control of your disk space usage. Okay, so it will have a table space to segments to extents to oracle blocks to os blocks. Okay, this is a logical storage structure. Okay. We'll just extend today 15 minutes more. Okay. We'll wrap it up this architecture. Everyone is fine to extend 15 minutes more? Anyone have anything?
I am okay.
Yeah. Yeah, we will. I will, because I wanted to show you guys those examples. Those are very important. So where you will get complete understanding of architecture. Okay. I just wanted to extend 15 minutes more to give you guys that explanation. Okay. And again, I will do the recap tomorrow also. Okay. But let's see, like, how much we can cover today. Yep. Thank you. Let's see, like, table spaces, segments, extents, oracle blocks. So these are all the storage granularly, how your data will be stored in the disk space. So let us move, like, uh, let I will talk about those logical structure. Let's understand the physical files first. Control files. So control files is one of the crucial file to open your database. Okay, without opening the control file you cannot read the database, open the database. Okay, so it will have a database name and location names of the data files associated with the database, and also redo log files locations also it will be having, and also it will have the timestamp of the database creation and the current log sequence number, also the checkpoint information. I told, right, checkpoints writes the scn information in the control file header also. Okay, that information also will be available in the physical file, which is control file, one of the physical file, control file. And the data file, every oracle database has one or more physical data files that belongs to a logical structure called table spaces. Okay, the data file is divided into smaller units called data blocks. Okay, so table spaces will have one or more data files. Again, logically, your data will be stored in the table space, and from table space, it will be stored in the data blocks. But table space will have a data file, one or more. Okay, minimum one. You can have a multiple data files to one single table space. Okay, in the example I have shown you, right, where here system have this system table space, sysocs will have this sysocs, and the user will have this user table space, and then undo will have a undo table space, associated table spaces. User can have a multiple table spaces if user actual data is growing. Okay, right now it is 5 MB only, but if it grows bigger and want to store in the many more data files, you can have them created data files. Okay, and have them assigned to the user table space. Okay, logically you will see user table space, but physically you will have a multiple files under the user table space to store the actual data. Okay, so that is the data file. And redo log file, you all know it will have the information, change information. So that redo log file information will be uh, written from the redo log buffer to redo log file with the log writer. Okay, and data file information also with the db writer, it will be saved in the data files from the database buffer cache. Okay, next, archive log files. Oracle can be run either of two modes, archive log mode or no archive log mode. I told you, right, archive log mode, when it is running, Oracle archives the filled online redo log files before reusing them and cycle them. And no archive, Oracle does not archive the filled online redo log files before reusing them in the cycle. Okay, so it reuses the redo log file again and again. It will not back up those changes to the archive log files. That's the difference, archive log and no archive log mode. Okay, so when you use, similarly, like, your SQL database, we will use archive log mode and no archive log mode. And you want to have a proper backups and wanted to have a point in time and wanted to store everything, you will go with the archive log mode with your database. Okay, so then let's come to the logical structure. This is how your logical structure looks. Your database is there, right? So your database information will be stored in the table space first. Okay, and then from table space subdivided into extents. So that information will be stored in the extents, and the extent information will be stored in the data blocks. Okay, so basically your data is stored at the end in the data blocks. Okay, whatever the logical structure comes in the picture in between, it stores in the data blocks only. Each data blocks, Oracle data blocks, will contains 8K. Okay, okay, 8K of memory. Sorry, storage will be allocated for each block. So first, uh, the you can see, you cannot change the data block size. Okay, it is remains same, but you can change the extents. You can have a two, uh, and you can wait. You can have three data blocks together can form an extent. Okay, or you can have a six data blocks can form an extent. Okay, so extent is nothing but collection of data blocks. Okay, extent is nothing but a collection of data blocks. Okay, you're clear, right? Extent is collection of data blocks. Okay, you can have any number of data blocks to make your extent. You can Oracle defines that. You can change that definition also. And the next one is segment. Extent you understand, right? So it's a collection of data blocks. Segment is collection of extents. Segment segment collection of extent is nothing but a segment. Okay, so you can have any extent be part of the segment. Okay, you can have three blocks extent also can be part of the segment. Five blocks extent also can be part of the segment. Segment is basically a collection of extents, two or more extents. If you are considering that, that is called as a segment. Okay, then next, so these are all blocks. Okay, so this is a segment. Okay, this is a, sorry, this is a extent. These two are extent. This is a segment. Okay, this complete one is a segment, this green space. So the collection of segments is nothing but a table space. Segment 1, segment 2, segment 3, segment 4 are nothing but a table space. Okay, so this table space will have a data file. Okay, one or more data file. Data file 1, data file 2. Okay, so this will have a one or more data files. This is how your actual data will be stored in the system. Okay, it will first go to the table space, then go to the segments, extents, and then data blocks. Even for reading also, it first reads from the data blocks, and then segments, extents, and table space. Clear? Clear about the logical structure? Any questions?
No questions.
Okay, okay. All right. So the next, we will be talking about the Oracle database architecture with examples. Okay, so this is very important. Now you guys will understand each and every component. Okay, so I have made a presentation with the process flow and all. So let's see what will happen. So when a client fires a query, you all ready to listen this, right? Or we can have this tomorrow also. If you are ready, then I can teach you, or we can have it tomorrow. This is one more important thing to understand exactly what happens in the architecture.
We can have it tomorrow.
We can have it tomorrow. If it is overwhelming, we can have it tomorrow. Yeah, then fine. We can have it tomorrow. I'll just give a brief. So what will happen with the user process initiative? Otherwise, we can have it tomorrow. Then no problem. We can freshly have these examples discussed tomorrow. So whatever we learned today, let's memorize that and understand each and every topic of the memory components, background processes, and physical and logical structure. So tomorrow we will complete these examples. So right now architecture is finished, but These examples will get you connected more closely to the architecture. So what happens internally of the Oracle database architecture when you fire a select query and when you fire a update query, etc. Cool. All right. All right then. Uh, any questions so far? Open for questions. Let's talk about any questions you guys have. Adam, Justin, Carl, Rahul. Any questions?
No, nothing right now.
So whatever I discussed, you all clear, right? Those concepts and topics.
Yeah, but I just need to go over again and see,
Yeah,
like,
yeah,
just to understand more.
yeah. So once I explain this examples, right, tomorrow, you will be completely understanding each and every concept. Okay, I will be detailedly explaining you what happens in shared pool, what happens in the buffer cache, what happens in the redo log buffer, everything. I will explain in detail. Okay, so I have all these animations done. So what exactly happens in each and every step, you can easily understand. Okay, so I'll give you complete internal understanding. Okay, even for the update also, what happens each and every step, how things works. Okay, cool. All right then. Thank you very much everyone for joining. Let's catch up tomorrow.
Thank you.